In a previous video, I described an overview of implementing Room with LiveData in Android. In this video, I'm going to take a quick summary look at that overview, and then we're going to jump right in and we're going to implement it. So first of all, one thing to keep in mind is Apple's iOS design guidelines say that if you have something like an autocomplete, you should be sourcing that autocomplete from local data. And right now we're violating that rule because we have an autocomplete and we're sourcing it from RESTful JSON data, which is great. It just means that we have network latency when we go out to fetch this data. And if we have local data, then we're fetching it locally from our device, and we don't have that network latency. So we can get the best of both worlds here. What we can do is fetch the data online, then store it in a local database, and then have that local database serve up LiveData, which our activity will listen to. So in other words, we have our JSON data that we're parsing with retrofit, and our activities can listen to that live data, and this already exists, but what we're adding is this piece down here with a room database which lives locally on the device, and live data that we're emitting via a query, a select query from this room database. So after we fetch the data online, the next thing we need to do is synchronize that data with our local room database, and then make that data available via a select query that returns a live data type, and then our activity can observe on that live data type, and it can update based on that state changing. So a couple things about Room. These are, again, things I covered in a previous presentation, but Room database is our local onboard database. We already have a plant data class. We simply need to decorate it with a few new annotations, including entity and primary key. We're also going to make a DAO interface, and we just need to define the interface in the function signatures. Room is going to take care of giving it an implementation for us, but we can guide Room by using some of these annotations here: DAO, query, insert, delete, so on and so forth. Now, observable queries, like the one we're going to create, will return a live data object, which means our activity can listen to that live data object. We also need to make a room database class, something that extends from room database, and that's going to help to put all of this together. Now, this is a slide we're going to come back to in a little bit because it shows the three big things that work together to make Room happen. First of all, we have our data class that we've already created, the one called plant, and we simply need to decorate it with an entity annotation on the top to tell it which table to save into. Then we have a new interface that we're going to make called, we're going to call ours iLocalPlantDAO, but it's going to have all of the CRUD operations that we want to invoke on our data. So create, read, update, delete, so on and so forth. And then we have this room database class that ties everything together. So if you'll see here from the entity annotation, we define our table name. We use that table name over in our DAO where we're saying what query we want to run. Additionally, the data class name plant we're going to reference in our room database extension to say, here is the data class that's going to represent the results we get back when we query the database. First things first, let's add some dependencies to our build.gradle for Room. Now, if we're using Kotlin, as I'm doing here, there's one more very important step we need to take, which is we have to use the capped annotation processor. So for that, I'm going to go towards the top where we have dependencies, and I'm going to add ID Kotlin-capped, K-A-P-T. Now towards the bottom, I'm going to take away this annotation processor note here, and I'm going to change it to capped, and then in parentheses, put the line that we had already with the Android Room compiler, Room version. And we see the red lines go away. If you don't do this step and you're using Kotlin, you'll get a strange error when you try to insert something into the database. It's Java lang runtime exception cannot find implementation for. And then after that, it takes an interface we're going to create a little bit later in the video and adds _impl, which is essentially Room making an implementation of that interface. So this annotation processor is important so that Room can look at that interface, make an implementation of it for us, and then provide that to us as a way to access the database. Now let's take a look at our class diagram and consider some of the work that we have going on next in the order in which we'll do it. So this is the class diagram we've been using throughout this project. We're going to need to make a plant database class that extends from the Room database class. And that's one of the things that we just imported in our build.gradle. We will need a DAO as well, and we're going to need a DTO, or a data class called plant. You might remember this from our presentation earlier as well. So the plant DTO we already have, we simply need to give it this table name annotation. The DAO, we're going to make a new DAO. We'll probably call it iLocalPlant DAO. It's an interface with the DAO, and we're going to need to annotate it with some query annotations. And then we'll make a concrete class that extends from Room database, and that's effectively going to tie everything together. So you can see the table name from our entity annotation is going to come right down into this query above our DAO. And then the data class name is going to be a type that we're going to associate with our database class and our database annotation. Let's jump in and do it. First, our existing plant class is easy. We simply need to add an annotation. And note that the import brought in AndroidX.Room.Entity, so that indicates that my Gradle build was successful. We also need to define a primary key, which is a unique identifier for the objects of this data class. And again, I can do that with an annotation, and I'm going to annotate the ID field. Note that it's an integer, which is good. And I also know, based on this JSON feed, that the ID is unique for each plant, so it makes for a perfect primary key. Now let's work on the interface. Let's take a look at some of the annotations that I've added and how they relate. So first of all, we have the @DAO annotation, which marks this as a data access object. And really, it's an interface, and Room will take care of the implementation for us. So all we need to do is define the function signatures and give them the proper annotations. Now, getAllPlants means we want to retrieve all the plants from the database. And we're going to retrieve it as a LiveData type that contains a list of plants. Now take a look at this select star from plants, and let's remember our plant data class that we created earlier. And we see table name plants. Now I originally made that plant. I decided that plants is more appropriate because it is indeed a plural type. Now the on conflict is important because if a row exists with this primary key, what do we do with it? And there are several different on-conflict strategies that we can try. So I chose replace, which is just right over it. But you see there are actually several more. There's also abort, ignore, several others. Replace works for me, so we'll use that. And then finally, we have the delete annotation. So that takes care of two of the classes that we wanted to make. The next one that we need to make is the Room database extension or subclass that's going to help to tie all of this together. A few things to note about the plant database class that I've just created. First of all, I put it in the DAO package. So you see, here's DAO. Secondly, it is an abstract class, and an abstract class means that there are details that should be filled out by a subclass of this or an extension of this. Don't worry, Room is going to fill out those details for us. Now, this abstract class has one abstract function, which is localPlantDAO, which returns the type iLocalPlantDAO. Because this is an abstract function, this is something that Room is going to do for us. So, but also remember that DAO interface is the one we just created. And I mentioned that an interface typically has function signatures, and we typically have a class that implements that interface. Well, Room handles all that magic in the background for us. So it will create an implementation of that iLocalPlantDAO, and then we will use this function to return that implementation of iLocalPlantDAO when we need to access the database. The other thing we want to take a look at is the annotation on the top. So at database annotation, entities is array of plant.class. So we're saving the plant type to the database. And then version equals 1. Now, anytime you change the schema of the database, you have to bump that version. And not the data itself, but the schema. In other words, the structure of the database. When that changes, you have to bump that version. Word to the wise. In an agile process, we typically iterate, and we work on one feature at a time, and we take that feature to completion before we work on another feature. For the database schema, you want to think a little bit ahead. Think what your roadmap's going to be and make a schema that's going to fit that. That way you don't have to go through that version upgrade, which is just a bit of work because you have to figure out how to extract the data from the old schema and then import it into the new schema. So if you can think ahead a little bit, that will save you a bit of effort on that conversion process. Now we need to invoke this all from our plant service. So we have our activity, we have our ViewModel, we have our plant service, and then we have our DAO. So the next step is the plant service, but there's one caveat. If we take a look at our class diagram, we can see the DAO here, and the specimen database will also tie into the plant service. And then the plant service is invoked by the ViewModel. But to access room database, we have to know what our context is. And the context is what describes our application. An activity extends from context. So if we have activity, we have a context. Currently, the plant service is wired up to the ViewModel, the main ViewModel that we have that doesn't know what context is. So we're going to need to do a little bit of refactoring here. And we're also going to have to pass a context object into our plant service. That's actually easier to do than it sounds, though, because remember we're using coin to create an object of this plant service type. And coin already knows what our application is. It already knows what our context is. So we can use coin to pass the application or the context directly to that plant service. And the main ViewModel doesn't even need to know about it. Let's take a look at that. Let's take a look at what I've added and changed here. So this class existed previously, and it did a simple retrofit call to go fetch plants JSON and then parse that into objects. So one change I made is when we get those objects, those plant objects, I pass it down to a new function I've created called update local plants. So update local plants, first of all, anytime we're dealing with the database or any kind of persistence mechanism, it's not a bad idea to wrap things into a try-catch so that we can do some logging if something goes wrong, and we also have the opportunity to set a breakpoint there in the debugger if something's going wrong and we can't figure out why. Always a good idea to do that. So I wrap it in a try-catch, and then within that I use the let operation to invoke this function only if plants is not null. So what do we do here? We get the local plant DAO. Remember, that's the interface we created a few moments ago. And then we invoke insert all on that local plant DAO. And once again, remember, insert all is a function we put on that DAO with the insert annotation and the replace on conflict strategy. Now, get local plant DAO is a local function I've defined below. And you notice what it does is it talks to room and it invokes the database builder function. It passes in application, which is our context. Remember that. And then it references that plant database class, which is the golden nail class that ties everything together, the class we were just working on right before we were here. And then it says, okay, the database name is going to be my plants, and then build it. Once we have that, we can invoke the local plant DAO function to get our local plant DAO. And what is this function? It's that abstract function we made just a few moments ago. So when we're dealing with all of these different classes that work together, the control click is really handy because it helps you to remember, oh, what is this I'm calling? What is this I'm calling? Now, if we take a look up towards the top of our main view model at the constructor, we see that we're defining a property called plant service of type iPlantService, and then we're giving it a default value, and the default value is currently redlining. Well, it's redlining because, remember, we have changed this plant service to accept an application as a constructor parameter. And in that default line right there, we're passing nothing into the constructor. So it says, hey, wait a minute. I don't have an application, so I cannot satisfy this constructor signature. Well, we weren't actually using the default anyway, and I don't want to have to pass an application in. So I'm just going to define this variable where it is here. Now remember, we're actually instantiating the variable with room, which is going to take us to this app module class. So in app module, we can take that application or context and pass it directly into the plant service when room instantiates the plant service. So we simply borrow this line from 11, Android application, and we reapply it down here in the plant service configuration line, and all of a sudden, red lines go away, everything compiles. Now let's remember how the main activity interacts with this live data. We have val plants by ViewModel dot plants observe his state. So it's hooked up to this plants live data on our view model. And if we take a look at the plants live data, it's immutable live data that currently is getting fed when we fetch our plants with the fetch plants function. Currently, that is accessing the JSON data feed and it's providing the data live. We're not currently wired up to get this from the database, but remember the whole idea is if we have a local autocomplete, we should source that from local data. So we need to change this live data. Instead of sourcing it from the feed of JSON data, let's go ahead and source it from the database, knowing that the database is actually getting populated from that source of JSON data. So let's work on that part now. In the main view model, I can change the assignment of this plants variable. Take away what we had before, and what I'm going to do is wire it up directly to the database that we'll access through the service. I know I'm going to have to do a little bit of refactoring in our service. We'll get to that in just a moment, but if I start this now, that refactoring is going to make a bit more sense. So plants equals plant service.getLocalPlantDAO.getAllPlants, and the getLocalPlantDAO is a function we already have, but it's not accessible to the view model. So I'm going to change the visibility of that function, and I'm also going to need to add that function to the iPlantService interface. And then getAllPlants is the query that we created on our interface that was just select star from plants. And that returns a live data type. So our plants variable here is still going to be live data, which means that where our activity is doing an observe as state, that's still going to work. The activity doesn't know anything changed. All of the changes are going to be in this main view model and also in the plant service. So let's take a look at the plant service and make a few changes here. First, we're going to invoke this getLocalPlantDAO from several places. And line number 47 is a bit of heavy lifting because it's building this database. We only need to do that one time, so I'm going to refactor this a little bit. First of all, we'll separate the declaration and initialization, and that allows me to move the declaration up towards the top of plant service and make it a late init. Now, let's see if it was initialized, and only do this initialization step if it's not initialized. Next, we want to expose this function so that it can be invoked by our main view model. So I'm going to take away the private, change that to override, and then I'm going to add this function to our interface. Once I do that, we can confirm that the red lines go away, everything compiles. After all the changes we just made to our service, we see that the red lines that we had in our main view model have now gone away. And now we can go back to this fetch plants function in the view model and remove line 72. Why remove line 72? Well, that's taking inner plants, which is the data that we got from the JSON feed, and that's posting that up to our live data. But remember, we don't want to get it from our JSON feed anymore. Instead, what we're doing is we're getting it directly from the database by using this construction plantService.getLocalPlantDAO.getAllPlants. So we're fetching the data directly from a local data source. But then we also know that that local data source is being populated from the JSON data feed in the first place. And if that's a bit confusing, let me just do a quick control click so we can look at that. So By the way, inner plants, we actually don't need that anymore either. That's just an in-memory representation of all the JSON that we were parsing. But we do still need to call the fetch plants function. So if we look into the fetch plants function, we know that we're getting our retrofit instance, which is going to let us parse the JSON. We know we do an asynchronous call to parse the JSON. We wait to hear back. All that's the same as before. But what's different is we're now calling this update local plantsfin, which is inserting those plants into our room database. Now, again, back to our main view model, we know the new construction we have here for plants is fetching those exact same plants from room, but fetching it in a LiveData friendly manner. So if the database changes, then our application can respond to that change by observing on the LiveData that is returned when we do that getAllPlants function on our DAO, which is invoking a query, select star from plants. And here on iLocal plant DAO, sure enough, you see select star from plants is above getAllPlants. So that wraps things up development-wise. Let's go ahead and deploy and watch this work. As our application starts to load, you'll notice the first time around, the plants collection has a size of 0, but it's still going to have to go fetch those plants in the background and populate. Let's continue. Now, we're using coroutines for this, and very important when you're debugging with coroutines. Take a look at this drop down here, and you might have breakpoints that cross different coroutines. So if that's the case, you can click on this drop down and go to a different breakpoint. In this case, we're in the fetch plants function, and I'll step over this and explain it. Remember that the first thing we're doing is getting our retrofit instance, which will allow us to parse JSON and read that JSON internally. Next, it invokes the asynchronous call to fetch the data. It awaits a response, and now it invokes our new call, where we're getting access to our local plant DAO, and then we're inserting all of these plants. And if you see right here, there are 5,950 plants that we're inserting into our local database. I'll go ahead and tell this to resume. Now here's the real test. We know that we have changed our LiveData to look at the database and not the stream of JSON data. So let's see if it will autocomplete when I start typing in the plant name. And sure enough, you see when I type east, we get eastern redbud, eastern hemlock, eastern white pine. So in this video, we've successfully seen how to take a source of data, which in this case happens to be online, save it to a local room database, and then use a fetch query or a select query from that room database to get a LiveData object back, and then have our activity observe that LiveData is state. And one thing you might have noticed throughout this entire video, I never touched the activity. Everything I did was behind the scenes at that ViewModel, service, and DAO layer. All I had to do was reconnect how we were instantiating the LiveData type called plants within our ViewModel. And the activity had no idea. So, as always, I hope this video was helpful, and I look forward to reading your comments. Thank you.